Welcome back to the Deep Dive, where we take a stack of sources and build you a mental map of what truly matters. Today, we are wrestling with, I think, one of the most fundamental challenges defining the current technological landscape. How exactly do we score the AI revolution?
It's a mission-critical topic. I mean, the way we evaluate generative AI has completely, utterly transformed.
Right.
We're just so far past the point of static text predictors. We are now dealing with these sophisticated, sometimes autonomous agents that can do complex reasoning, planning, even use tools.
And that transition, it demands a complete overhaul of how we even approach verification.
Yeah.
If you think back, last few decades, we went from these models built on manually crafted rules to deep neural networks, and now
Now to models trained on these colossal, multi-trillion token corpora.
exactly.
Yeah.
Our old strategies are basically obsolete. So our mission today is to dive deep into that history and then trace the cutting-edge methods like models, judging other models that define whether a modern AI in 2024, 2025 is actually reliable, safe, and aligned with what we want it to do.
And that history is just a perfect illustration of, necessity being the mother of invention. Every single time the models got exponentially smarter, the humans had to scramble to invent exponentially smarter tests.
So let's start at the beginning by leaving that old rulebook behind. For you, the listener, think back to, say, before the 1990s. This was the era of rule-based systems. We had things like ELIZA, right? The one that mimicked a therapist.
And SHRDLU. Yeah, they were fascinating, but ultimately so limited.
In what way?
Well, they weren't intelligent in any modern sense. They were just these elaborate, hand-coded pattern matching programs. They had very explicit rules. If a user types X, you respond with Y.
So the evaluation back then was almost binary.
Super simple. Did the input match the rule, yes or no? And if the user just shifted the input even slightly.
If you went off script at all.
The whole thing just collapsed. It had no real comprehension. It was fragile, easily broken, and its success was really just a measure of the programmer's effort, not any kind of intelligence.
And this inherent fragility is what the shift to statistical approaches, starting in the 90s, was all about trying to solve.
Right. Suddenly, with enneagram models and hidden Markov models, language became probabilistic, it was data-driven, and this demanded standardized statistical metrics that could handle all these new possibilities.
This is where we get the old guard of metrics,
Yeah.
the ones that, dominated for decades, but whose limitations are now just glaringly obvious. Let's start with BLEU.
BLEU, yeah. The bilingual evaluation understudy. It was mostly for machine translation. Its logic was pretty simple. Just calculate the enneagram overlap between the AI's translation and a set of human reference translations.
And the fundamental problem there is that it just completely failed to capture semantic meaning or nuance.
Oh, totally. You could have a translation that was perfectly accurate, totally fluent, but if it used a synonym or just structured the sentence a bit differently than the human reference,
BLEU would give it a bad score.
a terrible score. It's like grading an essay based on how many words it shares with the answer key and just ignoring whether the student actually understood the topic.
A similar problem plagued Rouge, right, which was used for summarization.
Exactly. Recall-oriented gisting evaluation. Rouge might tell you if the model included the right facts, but it massively penalized diverse summaries. If a model created an accurate summary that was just structured differently, it got marked down. It couldn't reward creativity, only strict adherence.
And then there was perplexity. Kind of interesting academically, but
But practically useless for assessing real-world utility. As models scaled up into the transformer revolution, these simple overlap metrics just couldn't tell us if the AI was actually, smart.
and that's when the whole game changed. Evaluation shifted toward measuring broader linguistic understanding and really deep reasoning.
The arrival of the transformer architecture, the thing that powered BERT and the early GPTs, it meant we needed benchmarks that tested complex inference, not just counting words.
So we got early successors like GLUE and then Super GLUE. They standardized things like coreference resolution, multi-sentence inference.
We were moving beyond just understanding a single sentence. The question became, can it connect the dots across an entire document?
But this is where it gets really interesting with this idea of emergent capabilities.
Yes. Researchers found that certain advanced functions, like multi-step reasoning, mathematical deduction, they don't appear gradually. They just sort of emerge once a model hits a massive, massive scale.
Which forced the creation of these massive multitask benchmarks. Okay, let's unpack the king of these, MMLU, the Massive Multitask Language Understanding Benchmark. Why is this the academic gold standard?
MMLU is critical because it moves way beyond just language tasks. It asks a model to act like a university student. It evaluates knowledge across 57 different subjects.
57.
Yeah, from high-level math and physics to political science, law, history. It quantifies real-world expert utility. A high score means the model can reason across specialized fields, not just, recite facts it saw online.
And we also saw benchmarks like Big Bench, which had something like over 200 tasks.
The whole point of Big Bench was to find things that models should be able to do but maybe weren't explicitly trained on, to test for generalization.
And for pure logic, there's GSM-8K.
Right, which isn't about facts at all. It's 8,000 multi-step math word problems. It's a test of pure logical procedure.
This incredible scaling really highlights the core challenge for the industry today: alignment. It's not enough for the model to be intelligent anymore.
No, it has to be safe, honest, and actually adhere to human values. A superintelligence that isn't aligned is, well, that's a problem.
And that's why we have things like RLHF.
Exactly. Reinforcement learning from human feedback. Human reviewers grade the model's output not just for accuracy, but for helpfulness, honesty, and harmlessness. RLHF is the tool we use to try and bake those values into the machine.
So, as soon as the models mastered text, the next frontier was, of course, seeing. And we have to move beyond text now because we're in the era of MLLMs, multimodal large language models.
Which process interleave text and images. And that requires evaluation methods that demand not just common sense, but expert-level perception.
The major benchmark here is MMMU, massive multidiscipline, multimodal understanding. This sounds intense.
It is. MMMU has 11,500 college-level problems across 6 disciplines, 30 subjects. But what's really unique is the kind of images it uses. This isn't just asking, is there a cat in this photo?
Okay, so what are we talking about?
We're talking about chemical structures, sheet music, engineering blueprints, medical scans like X-rays or MRIs.
So you're forcing the AI to perform tasks like a human domain expert, someone who has to integrate visual data with deep knowledge to solve a really specific problem.
Precisely. And you see others too, like MathVista, which combines algebra with reading graphs and plots, or MIA Bench, which tests how well a model can follow really specific layered instructions on an image.
If you connect all of this, MMLU, MMMU, all these specialized benchmarks, it puts an incredible strain on human evaluators.
Oh, it becomes completely impossible. I mean, think about the scale, the cost, the inconsistency. You'd need global teams of doctors and lawyers and engineers just constantly grading AI responses. It's way too slow, way too expensive.
And that inefficiency led to this really fascinating idea: the LLM as a judge paradigm.
It sounds a bit strange, but you use a highly capable model, like a GPT-4, to score the responses of other models.
It's like letting the valedictorian grade everyone else's homework.
It is, but it's a necessary evil given the scale. And the key question, of course, is trustworthiness. Like, why should we trust one AI to judge another?
And the sources point right back to RLHF.
Absolutely. Because those top-tier models have been so rigorously aligned through RLHF, they show really high agreement with human preferences. We're talking 80 to 85% agreement with human experts.
Which is about what you'd get between two human experts anyway.
Exactly. They're good judges because they've had our standards safe, helpful, honest, reinforced over and over.
But if the judge model itself is closed source, proprietary, that creates a bottleneck. And this is where it gets really interesting, because the open source community responded.
They built their own judges. That brings us to Prometheus 2. It's an open source model fine-tuned specifically to emulate the scoring capabilities of those big closed models, but with transparency and control.
And Prometheus 2 has two key grading modes.
It does. It has absolute grading, where it gives a score, usually 1 to 5, based on a rubric. And then there's relative grading, which is just a pairwise ranking. Given 2 responses, which one is better? That relative ranking is often much more reliable.
Okay, moving from grading intelligence to guaranteeing safety. Evaluation has had another huge shift here too. We're moving away from static, keyword-based toxicity checks to dynamic adversarial red teaming.
Red teaming is no longer a one-off thing. It's an interactive, iterative loop. You have human teams or even other AIs actively trying to find vulnerabilities and failure modes before they can be exploited in the real world. It's a constant arms race.
And what are the key metrics they're targeting?
It's pretty straightforward but hard to achieve. They want to get the attack success rate, or ASR, for harmful requests down below 5%, and they want their testing coverage, making sure they test for all kinds of risks, to be above 90%.
So based on current research, what are the cutting-edge ways teams are trying to break these systems?
We're seeing three main attack vectors. First is simple, direct injection, just a clear, explicit request for something harmful. The model just needs to say no.
And then you have the more uh, social engineering approaches.
That's role-playing. The attacker asks the model to bypass its safety by pretending to be a villain or asking for dangerous info for a fictional script. The model struggles because it wants to be helpful and play along, but that conflicts with being harmless.
And finally, the more technical attacks.
Obfuscation. Using things like base64 encoding or leet speak to confuse the model's filters. An attacker might encode a dangerous prompt into a string of random-looking characters and ask the model to decode it and then follow the instruction.
Which makes the defender's job incredibly complex. But beyond these attacks, there's a more subtle, almost existential threat to the whole evaluation system: benchmark data contamination.
This is a massive headache. It's one of the biggest reasons static leaderboards are losing their credibility.
Explain that. What is it?
It's when the actual test questions from MMLU or SuperGLUE accidentally get included in the model's pre-training data. The model then just memorizes the answers instead of learning how to reason.
So it's like it passed the exam because it had the answer key ahead of time. The scores get inflated and the whole benchmark becomes invalid.
Precisely. And the mitigation strategy is a big shift toward dynamic benchmarking, where data sets are constantly updated or regenerated.
We see this playing out on the leaderboards themselves. Hugging Face's Open LLM leaderboard, for example.
Yeah.
They saw all the top models getting near-perfect scores, so they just swapped out the easy benchmarks for much harder contamination-gated ones like GPQA.
Which brings us to a crucial separation. The industrial versus the academic approach. They have very different goals.
Right. The academic world with the leaderboards is focused on general intelligence, novelty, pushing the state-of-the-art with things like MMLU.
But an enterprise deploying AI accuracy is only one piece of the puzzle for them. It has to be balanced against operational KPIs. Cost, latency, compliance risk. They're not chasing leaderboard points, they're chasing performance on mission-critical tasks.
So if you're a company using a RAG pipeline retrieval augmented generation, your evaluation is going to look totally different.
Totally different. Your number one metric is factual grounding to prevent hallucinations. You measure this with faithfulness, the ratio of claims in the answer that are actually supported by the source documents. An answer that's brilliant but completely made up is a huge liability.
And second, you have to make sure the system found the right documents to begin with.
That's retrieval quality, measured by things like precision and recall. You need high recall to find the right needle in the haystack of documents, and high precision to make sure the top results aren't just junk.
The sources seem to characterize 2025 as the year of AI agents, and that shifts the evaluation focus one last time. We're moving from grading the final text to grading the entire autonomous system.
It's a huge leap because the agent's intelligence is defined by its actions, not just its words. So we need these specialized agentic metrics. Tool correctness, did it use the booking API correctly? Task completion, did it actually achieve what the user wanted?
And critically, role adherence.
Role adherence is essential for enterprise safety. You have to ensure the agent stays within its authorized boundaries. A customer support bot, for instance, should not be giving out legal advice. The evaluation has to confirm it sticks to its role throughout the entire task.
So we've really charted this whole evolution, from just counting words with BLEU to assessing expert knowledge with something like MMMU. We've seen the pivot to using AIs to grade other AIs with systems like Prometheus 2, and this intense effort to break them with red teaming.
And the overall direction is clearly toward trustworthy productivity, where these complex autonomous agents are governed by robust, continuous, and dynamic evaluation. The reliance on multi-step verification, on chains of thought, means verification itself is moving inward.
That's a profound thought. That future AI reliability might not rest on verifying the final answer, but on verifying the thoughts of the model, measuring the faithfulness of its internal reasoning process. What does it mean for us when we have to start monitoring the internal thoughts of an AI to ensure it's safe? That is a question we will all be grappling with as this revolution continues. Thank you for joining us for this deep dive.